Hello, welcome. Another episode on menstruation 2. In this episode, we are taking a question under WASI SSC 2003 on a cone and that of a cylinder. All right, so we are taking this question: a solid metal cuboid of height 3 centimeter, length 11 centimeter, and breadth 4 centimeter is melted to form another solid consisting of a cone and a cylinder joined together. So as we can see in the diagram, so the height of the cone is 4 times that of the cylinder. You can see it 4x and x, and the radius is 3 centimeter. The radius of both the cylinder and that of the cylinder and the cone is 3 centimeter. So assuming that no material was lost, we have to calculate 1, the height of the cone, 2, the volume of the cylinder to 2 decimal places, then total surface area of the solid. So at this point, look at the question, look at the diagram, and pause the video and solve it. Don't forget, we have delved into the tutorial on finding the total surface area, the volume of both cylinder and the cone. Try to apply that concept if you've watched the episodes with us. All right. So now, the first thing is that a solid rectangular shape, which is the cuboid, is being melted. They said if we assume that no material loss, all the candle melted into solid, into liquid, we use all the molten form to create another one. It means the volumes of the cuboid and that of the new solid form will be the same. So if we can be able to associate that, then we can find the volume of this, and that should be the same as the volume of the original material. So let's take it from there. So first of all, we can say volume of cuboid. You can write this in words, but we don't have enough space. So volume of cuboid, we know it is length times the breadth times what? The height. And that will be length is 11 centimeter, the breadth is 4 centimeter, the height is 3 centimeter. I guess this will be 12. 12 times 11, 132, right? Then centimeter cube. So if no material is lost, then the volume of the cuboid will be equal to the volume of the new solid. So if no material loss, then we can say that volume of cuboid will be equals to volume of new solid. You write all these in words, but we are managing the space. Okay, so now the volume of this equals to the volume of the new solid. But how do we find the volume of the new solid? It is not a singular three-dimensional shape, it is two joined together. So the volume of the first one plus the volume of the second one give us the total volume of the new solid. So we can say that volume of new solid will be equals to volume, let me just do the abbreviated form, volume of what? Cone plus volume of cylinder. And I believe the new volume here is going to be 132. So we have 132 equals to volume of cone. Remember, the formula is 1/3 the volume of the cylinder. So 1/3 pi r squared plus pi r squared, I think there's h, plus pi r squared e. This is the volume of a cylinder. 1/3 of this give you the cone. So what do we do from here? We do substitution. So 132 equals to 1/3. Then we multiply by 22/7, which is the pi. Then times the radius in 3 centimeter to 3 square times the height. Where is the height? This is the height. So 4x. Then plus We have our 22 on 7 times the radius will be the same. 3 squared times what? X. I believe we can be able to associate that and say that this is the volume of the cone. 1/3 pi r squared plus the height, which we are seeing here to be 4x, plus the volume of the cylinder, which is pi, that is 22/7, times the radius squared. We know the radius is the same, 3 centimeter, then the height is what? X. So let's solve the right hand side and equate it to the left hand side. So if we have this, we will be having our 132 equals to 1 times 22 times 9 times 4x. That will give us, on our calculator, 264, then your x divided by 7. The whole of this as a numerator, this as your denominator. So you will multiply, then plus 22 times 9, and that will also give us 198 times the x divided by 7. Here we can decide to multiply through by 7, which is the LCM, or we solve this as a unit fraction, as a like fraction, adding the numerators. Meaning I'll be having 132 equals to adding 264 plus 198. And that will give you 462x divided by 7. So if you divide that by 7, you'll be having 66. So I'll be having 132 equals to 66x divided by 66. Your x will be equals to 132 divided by 66, and that will be nothing but what? 2. And this 2 is going to be in centimeters, right? Okay, let's leave it. We are to find the height. What we are looking for is the height of the height of the cone. So the height of the cone is from the apex to the base, and the base to the apex is 4x. And what is the value of x that we arrive at? We arrive at x being equals to 2. So in this case, we can say that, therefore, the height of the cone will be equals to 4 times x, which is 2. And that will give us 8 centimeters. So if you look at this, the height of our cone is going to be 8 centimeters. I guess we grab that concept. Good. We are finding the x for the purpose of the height. Then number 2, we are to find the volume of the cylinder. You know, to find the volume of the cylinder, we are coming back to the same place. If I like, I will only do substitution in this case, whereby the value of x is going to be 2. So right here, in the case of this, 198x over 7, that is the volume of the cylinder. So we are picking that and do our substitution. So the number 2, which is the volume of cylinder, we know it is pi r squared h. So we are only going to do our substitution. So volume equals to 22 on 7, 3 squared times what? 2. Don't forget our height is going to be 2. The x is the height of the cylinder. So that will be 2. Then when you multiply all this, divided by 7, and that will give you 56.57 centimeter cube. We are leaving our answer into 2 decimal places. So that gives us 56.57. So that is the volume of our cylinder. The volume of the cylinder, only here. The next thing is to find the total surface area of the whole thing. What will be the total surface area? Total surface area is the surface area of that of the cylinder plus the total surface area of that of the cone. But you can see that if I am using two material, when I join them, this used to have a circle. So this is a circle. If I am joining another material which is also having a circular part, when I join them together, the two circular parts cannot be together. We have to remove the circular part in order to have the material being complete. So that if in case we open the base, we can pour in material that will pass through the end here into the cone. So there will be no circular part of the cylinder and there will be no circular part of that of the cone also. So it means the cone will be made up of a hollow shape, which is the curved surface area. Then the cylinder will also made up of only here as a circle and the curved surface area without the other circle. I believe you get the concept. So let's see how we can build that into that. So number C, total surface area of the new solid will be equals to the total surface area of cone plus total surface area of what? Of cylinder. So if you are taking it one by one, that is taking the total surface area of a cone. Ask yourself, do you have all the dimensions? Total surface area of a cone is just, in this case, is the curved surface area. Pi r L. L, which is the curved surface area here. So if I take this, this is the L, this is our 8, this is our 3. We need to find the value of L before we can be able to find the volume. So from here, using Pythagoras theorem, you can see L squared will be equals to 8 squared plus 3 squared. Then we do that and see what we can get. So from here, you'll be having L squared equals to 8 squared will be 64, 3 squared will be 9. Then from here, we can take it as L equals to the root of 73, and that will make your L equals to root 73. That gives us 8.544. Let's leave it on 4, okay? Let's take it to be 4. That is the slant height. But our attention is on total surface area, right? So total surface area of cone is equals to pi r L. So per your substitution, you have 22 on 7. R is still the radius. Then you have your 8.544. Let's see what that will be. And here we are going to have 80.56. What are we looking for? Surface area, so centimeter squared. Then we can also take the total surface area of the cylinder, which is going to be the base area, pi r squared, the curved surface area, 2 pi r L. If you do your factorization, you will see pi being outside, r being outside. Dividing this gives you r, dividing this gives you only 2h. So we can do our substitution. 22 for pi over 7 times 3 into bracket 3 plus 2 times the height of what? The cylinder, which is also 2. Let's compute this. So I believe we can have 66 total surface area. So cylinder will now be equals to, so we have 66 centimeter squared. So 66 become the total surface area of the cylinder. So let's go for total surface. Let me make it therefore the total, let me use the abbreviation, of the new solid will be equals to 80.56 plus 66, and that will give us 146.56 centimeter squared. We are leaving our answer in 2 decimal places. Again, you take your time, follow from the beginning to where we are, breaking it down step by step. You'll be able to get to this place. Thanks for watching. Like, share, and comment. Don't forget to subscribe and follow us on Facebook. Bye-bye.